Okay, in this video we're going to talk about the difference between an intensive and an extensive property. So you'll read about this in your textbook, but this is just one thing we want to make sure that we cover and clarify. All right, so the key is intensive means independent. And I'm writing with my finger on a screen, so if it looks ugly, don't worry about it. All right. So what an intensive property, it means it's independent of the amount of the thing we're talking about. Okay, so a really good example of an intensive property is temperature. So I have a beaker here, and the water is at 20 degrees Celsius. If I take this beaker and I pour it into another beaker, so now I have two beakers, the temperature of the water is 20 degrees Celsius there and 20 degrees Celsius there. So temperature is an intensive property because the temperature of the water doesn't depend on how much water I have. It just depends on the speed of the particles moving in the water. So what this has to do with independent is the temperature is independent on the amount of water. It does not depend on the amount of water. All right? An extensive property, on the other hand, is one that does depend on the amount of stuff. So the easiest one to do as an example for an extensive property is mass. If you have the mass of 1 penny, it's about 1 gram. But if you have the mass of 2 pennies, it's 2 grams, and 3 grams if you had 3. So the mass of the pennies depends on how many you have. So it is an extensive property. All right? Now, I want to use mass as another example here to kind of clarify this as well. If we take mass, which is an extensive property, and we divide it by volume, which is an extensive property as well, because the volume of Mountain Dew in my cup is directly related to the amount of Mountain Dew in my cup. So the amount does determine the volume I have. All right, but if I take mass and I divide it by volume, I end up with density. And these are both extensive properties, but density is an intensive property. Because density, it doesn't matter how much of something you have. The density is consistent throughout. So for example, let's use pennies again. So if I have 1 penny, its mass is around 1 gram. 2 pennies, its mass is around 2 grams. 3 pennies, let's say it's 3 grams. So this is mass. The volume, I don't know, I'm going to make this up, but let's say that the volume of 1 penny, it occupies 2 milliliters. Then 2 must occupy 4, and 3 must occupy 6 milliliters. And the density then, we'll put it over here, density equals mass divided by volume. So I take my mass, it's 1 over 2 for 1 penny. All right. For 2 pennies, it's 2 grams divided by 4. And for 3 pennies, it's 3 grams divided by 6. Now, you hopefully are good at math. 1/2 reduces to 1/2. 2/4 reduces to 1/2. And 3/6 reduces to 1/2. So you will notice that the density of these pennies remain the same no matter how many pennies I have. You will notice, though, that these change depending on how many. All right? So these, extensive, they depend on the amount. Density, intensive. It doesn't matter how much stuff we have, the density will remain the same. So just one little nugget. A ratio of 2 extensive properties, I'm going to abbreviate there, will produce an intensive property. So my mass divided by my volume is equal to my density. And we can see this represented on a graph as well. If I have a simple graph of mass versus volume, and I plot those points, and then I connect them with this smooth line, all right, you will notice the volume is getting higher the farther we go over this way. You will notice the mass as we go over this way is getting higher. But you will notice if we take the slope of this line, no matter where I am on this line, the slope is always constant. Whatever. Constant. A constant slope would mean it's independent on how much there is. All right. Hopefully that helps clarify and shows some relationships of extensive and intensive properties.